Oh, okay.
Because we're the consortium is quite unusual, maybe, that we have 2 theory groups plus a lot of experimental, so that you've got quite a strong theoretical support. And is theory giving you what you want at the moment, or what is it? Do you want more from us, or less, or different things, or?
I think that the theory and the experiments have progressed in parallel so far. We have made some tests. You have made some calculations, and now we reach the point where we will have to merge that stuff. And of course, that will bring for you new calculations, and for us probably new experiments. So far, I find that it's going quite well indeed.
Jean-Jacques? And it's not too much to have 2 groups, theoretical groups working on this subject, because you are quite complementary too. You are not duplicating each other. As I understood, I don't know, Irene or Zera is bringing pseudo potential for the other. You are complementary regarding interaction of molecule with metal clusters with the carbon nanotubes. I think the ensemble makes a quite well-balanced consortium.
Yeah, I wouldn't say too much, but yeah, there's quite a strong aspect of the project for me, that having 2 theory groups means that we can divide the work.
You can divide the work, and I understood that you are complementary. You are not duplicating each other.
No.
And if we like to understand the way the sensors will work, we need some theoretical background. We need as well, on the experimental point of view, we need as well some work on model systems. So we'll go to definite metals, definite materials, we'll go to model materials too.
But to maybe catch on your point that there's not just the parallel, but we've had parallel theory as well. So.
Yes, I have a question for you. During the lunch we were speaking about the fact that nanotubes are not well known today. Maybe on the theoretical point of view you can model that, but you said that there is no real estimation of the quality of the nanotube. So we don't know how many defects, how many stuff we have, and the purity of the nanotube and so on. How can people in theory groups like your group, how can you do calculations on a model system while we are forced to work with a completely unknown system?
That's a good question.
Thank you. I appreciate it.
I mean, I would say that we work on defects in our group here. So we are trying to look at defective tubes. So we're trying to move away from model system towards more realistic systems. We looked at things like defects linking tubes together, and what happens when you bend tubes and fold tubes, and the sort of local structural defects. Because it's true, when you look at the microscope images, they're not these little perfect tubes at all. We have to do it a step at a time, because the complexity of what you're talking about is more than most calculations can cope with. But I mean, for example, we're looking at the moment at very small vacancy defects with a bit of oxygen, and we're saying, well, it's a first approximation to what's probably going on, which is a lot more mess and a lot more. But it's a pointer, it's a guide.
Ok.
Is that
fini? Batterie est morte.
Ok, tu fais un zoom sur les 3 intervenants, sur tous les spectateurs là.
Ok. Et puis, ça va, c'est bon?
Say give me love, give me love, give me love, give me love, give me love. My baby, give me love, give me love, give me love, give me love.